Thank you. Nice to be here. So Stilride was founded in 2020, so we're a young startup, and we founded it with the ambition to pioneer a greener future. And how do we do that? We actually use the ancient art of origami that you might have heard of, and we don't just use origami. We use something we call kurvogami, and I would like to start this out with you actually raising yourself, standing up. All of you. You're going to be able to feel the power of the curve. And raise up your hands. Close your eyes. And bend backwards. As far as you can. Until you feel the stretch. And there, the power of the curve. So we work with curved folding in combination with straight folding. It sounds simple, but evidently it's not. And it all started with a piece of paper, actually, at my friend Tuve Beyer, who's an industrial designer and engineer as a background. He showed me this model that he folded of a bike chassis. And Tuve is a Vespa fanatic. He's been driving old Vespa since he was 15 or even younger, before it was legal, when he was 14. And he's actually, we had this common interest in Vespas, and we were mods together at that time, early 80s, 90s, and he showed me, what if you could fold this in a piece of metal? And I was fascinated by that idea. So we took this further. And the story that went on from this is also that Tuve has been exploring this since he was 19 with this model that you see here that we have in our office, which kind of reminds of the actual product we're making now. So the idea has been around since 30 years. He's been folding cars since then, and we've been telling this story to a lot of people.
Jag heter Tuve Beyer, är industridesigner, och Stilride, det är ett sätt där vi vill undersöka den platta plåtens fulla potential.
The Swedish electromobility and industrial tech startup Stilride uses robotic arms to fold steel over curves to create shapes which have been used to build its inaugural electric motorcycle. The process has been described as industrial origami, and the company's just raised 3.7 million euros to help fund its rollout. Well, joining me now is the chief executive and co-founder of Stilride, Jonas Nyvang. Jonas, welcome.
Mitt namn är Jonas Nyvang. Jag är vd och marknadschef för Stilride. Vi började egentligen med den här modellen som Tuve visade på en middag hemma hos sig, och hade en poetisk tanke om att vika fram en elskoter utifrån en plattplåt. Och det här lät ju superspännande, tyckte jag. Stål har ju många intressanta kvaliteter, framförallt då att det liksom har en lång livslängd och kan återanvändas.
När vi viker plåten för att göra vår konstruktion så liknar ju det till viss del det man gör i origami. Det vi gör lite annorlunda här, det är att vi viker över kurvor. På så sätt så får vi en annan dimension till det hela, därför att vi går från det raka planet. Och för att kunna liksom replikera det exakt så gör vi det med robotar. Det är ju som en dans mellan robotarna, och själva resultatet av deras dans blir ju produkten i sig. Alltså framtidens för stål, otroligt spännande ska jag säga. Jag tror ju att det är de teknikerna vi kopplar på tillsammans med stålet.
Obegränsad, det är ju som vilket material som helst, men det har ju en extremt hög hållfasthet, liksom återvinningsbarhet och
Det är väldigt flexibelt, så att på så sätt så tror jag att det finns massor med möjligheter att hitta på saker åt stål.
Det sättet vi jobbar på nu, det är ju ett sätt att öppna upp möjligheterna med stål. När vi tittar på om vi kan koppla ihop AI och själva vikprocessen, då kan vi reducera materialåtgång, vi kan optimera styrka på ett helt annat sätt än vad vi skulle kunna drömma om.
Yes, so it all started with me actually going up to the Steel Industry Association in Sweden, showing them a paper model of a folded chassis, and they believed in us. Hard to think about that, you know, but they actually gave us funding and a grant to be able to do our first prototype of this or demonstrator of this product. And that also made us, we could take the leap, you know, we were both like late 40s. I have 3 kids, he has 2 kids. You call it the golden cage, well-paid jobs, you know, a lot of responsibilities. To kind of leave that and jump to startup, you need some security. So they provided a startup investment for us, and that we're super thankful for. And then when we released the first images of the bike, we actually got the viral effect of the bike. So we started getting sign-ups from all over the world, even in Cambodia and Ecuador, and 15 markets in total. And that made us really believe also that we could raise capital. So then we did that, and we also created a technology on the way, not just a product. And we call this STILFOLD, which is our form of industrial origami. We use robots to fold, and we use this proprietary software to be able to find the folding patterns to realize the full potential of flat sheet metal. And what's different with this? I mean, what we're doing is that we're taking back the higher refinement to the workshop, just like the blacksmiths did. We're using die-less manufacturing instead. We're using an incremental forming technique where we fold along an English wheel with robotics. And we have a folding mechanism mechanized around that, so we can do it in a quite good tempo. And other than that, we use ordinary processes like cutting out the pieces and welding them together. And what we really focused on at the beginning was the mobility sector, because we think there is a lot to be done in the mobility sector. It's a huge depth that in sustainability and CO2 emissions that this industry has. And the main problem is that there's a legacy structure in how you actually make cars and vehicles. And there's a lot of parts, and of course there's a lot of tests and crash tests and stuff that has to be taken care of. But we think there's simplification to be done. You can rethink this and reduce. So what we want to do is to actually use the metal, sheet metal that's around, as green as possible, fossil-free as possible, and decrease the number of components as well, through actually folding them and through that part integrating them. So using the right material, as little as possible, will be our task going forward. And also to actually take out the dies as much as possible. There will always be dies, but in many situations we think that can be replaced by bending and folding. And especially now when the software is so advanced and the computational power is so strong, then we can find new ways of actually making robots enabling this forming process. And what we do is actually we cut out parts that we optimize as much as possible from a flat sheet. We have the manufacturing procedure, and we optimize that in 2D to realize the 3D shapes. Actually putting together the geometric properties of the fold with the material properties. So we have limitations, of course. We can't do more than 4 millimeters thick material at the moment in our current setup. But we have tested it on much thicker with different setups that we don't have in-house. And we've tested it on most of the car metals, aluminium, different auto sinks, different stainless steels, etc. And there is a lower barrier of when it's too flimsy, not rigid enough. It needs to have some plasticity so to be able to fold. But what we do now is actually we do this focused on our own bike that we call Stilride 1. And it's an electric motorcycle with that goes 100 kilometers an hour. And I was glad to see that it was on the cover of Develop 3D. And the big thing about this was that we managed to show the technology benefits in the chassis. And the chassis is actually made up of 6 parts from the beginning. We took a part like a competitor product called the Neo, and this dissected their tubular chassis. We could see that had 159 parts, weighed 55 kilos, and had 20 plus materials. We managed to reduce that. Now we're down to 6 parts, actually, not 20 parts, and 9 kilos with 1 stainless steel fossil-free circle green material from Autocompo. So the reduction in weight was the big thing that we wanted to achieve, but through that we also achieved fewer components, lower material cost and lower labor cost because there's so few steps in putting this together. And this chassis is a great example of what else we can do with this technology. I mean, if you look at the top one there in the middle, that's the beam that we use that creates the rigidity in the structure. And from that comes the surface structure. And if you put the surface structures together, that creates an exoskeleton. And this can be used in different applications. We haven't tried it on all, but we think that could be used on A surfaces for automotive. Furniture, we worked with a big Swedish furniture maker on substantially drastically reducing the tempos on an armchair. We're working on automotive structures now with the client. We also work with foundational structures, and we tested it on transport. So from this simple chassis, actually, we got some really great ideas. And to take this into the public, there's a bridge in Stockholm which is very debated or discussed. It's called the Golden Bridge. It connects the south to the north. And it was actually made not in Sweden, but in China.
The Golden Bridge in Stockholm is made out of steel, weighing in at 3,400 tons. Built in China and transported to Sweden in one piece, it went on a voyage with an environmental impact equal to 3,000 transatlantic flights. The total carbon footprint, including material, building, transportation, and assembly, is calculated at roughly 15 million kilos of CO2 emissions. What if we would have used STILFOLD instead? An industrial origami process used to fold the bridge on site in a stronger yet lighter design. In the case of the Golden Bridge, this would mean the possibility to use Swedish steel with a much lower environmental impact. This would also mean stopping 9 million kilograms of carbon emissions from ending up in the atmosphere. The green steel revolution is just around the corner. Now, let's pioneer a greener future through STILFOLD.
And then from this film, we were contacted by a trailer company in Sweden, actually, like a big trailer company for trucks. So what we did with the bridge, and thought, can you do something about our trailer chassis? And we thought, yeah, why not? And we did the first case study on that. They just dissecting their trailer chassis that's been around for about 70, 80 years. A lot of parts, and made it into a dream structure of 6 parts. This is not where we're going to end up, probably, but that's just a great example of how much you can reduce by folding. By taking down 30% of the material in the chassis through folding it, we could also increase the payload that you can put on the trailer with 5%. And that made the biggest trailer company in the UK interested, Maritime Transport. And also the European leader in trailers, Cargo Bull, Schmidt Cargo Bull. So we're in those discussions now. We don't know where it's going to go, but it's clearly inspiring to see what you can create with a case study. And it looks pretty cool as well. It's a kind of a different structure than the ordinary straight ones. So what could we do with this process? We believe that instead of shipping stuff from Asia to Europe, we want to enable people to produce locally. And that's our dream, is to actually be able to provide this process in a container format. So you can actually just ship out a cell to a metal workshop in Italy if you want to produce the bike there or something else. So we can just use our software to transfer the code and the folding patterns to be able to fold it on site. And through that, having less footprint in logistics and be able to have local empowerment of workers, etc. And we've been mapping what we could do, in terms of structures. And clearly there's a lot of possibilities. Everything from big one unit structures like bridges architecture to small bespoke structures like our own bike, but also more high volume standard structures that could be tool based, like automotive or furniture. So, and we also, this is a wild idea that Tuve came up with, and we first thought, this is really off target. We're doing mobility and light structures, Why look into foundation, but why not?
When cultivating nature's powers, we transplant human technology into nature, relying on old methods when we should be paying attention to Earth, to where we are, and ask ourselves, right here, in these conditions, what would nature do? Every root of every tree is unique to where it's growing. We know this. This wind turbine, we can either force it down, overcompensate, or we plant it like a tree, connecting it to the ground with the ideal foundation for any terrain. With a folded triangular section and 3 connecting points, we're mimicking the tree root, allowing nature to teach us about standing steady. Let's create a greener future, one fold at a time.
And this case study was actually generated by a large foundation builder called Payco that gave us the data because it's a lot of requirements on building a huge foundation for a 160-meter high tower that's going to be standing, taking wind power. So we connected up with our steel expert and his favorite load analyst, and from that worked for Scania for many years, and we did the analysis. And the interesting part is, I mean, it looks like it can work. This is a long-term project. It's going to take us 5 to 10 years until we can get something up and running. But I mean, it's a fascinating thought to be able to take out the concrete, and that is normally for these type of wind turbines, 100 trucks, full trucks of concrete are going out in the, to very isolated places, and you have to create infrastructure for these trucks to be able to go there even. Instead, you could actually have these structures just like the propellers going out on the trucks. That's instead of 100 trucks, about 10 trucks. And this actually triggered 3 wind turbine companies contacting us and wanting to look into these type of structures. So it's the power of prototyping and case studying is clearly a great way to do marketing. And another case we're working on at the moment that I went to saw Polestar yesterday. We're working with them on Polestar 0, their first climate neutral car. A super high ambition to create everything from the material has to be totally 100% zero in its manufacturing process. All the steps, even the tires, have to be zero. So the ambition is to create a process that's much more resource efficient. And what we're looking at now is different parts of the car, battery packs, and folding structures, making crash structures different, and it's a great learning experience. And here we got to use, here you see how you can go from 2D to 3D, actually mapping with our software, mapping out the foldability of the structure, so it fits the frame. And the last project we were working on now that we announced this week is a project with Alstom where we're taking a look at their new trains and what we can fold in the kind of the carriages and the front of the train. So it's origami is opening up a lot of doors, which is fascinating. But our first showcase is where we have the most focus. So we're taking this product to market, and it's a high-end scooter. It's like Hypist wrote, the Porsche of scooters. And why is it that expensive? Yeah, because we have no volume yet. To have any margin, we need to have a high price. But it's our dream product, and we have a team of 8 people working with it at the moment, and we're going to produce it in Sweden just like we want locally. And I hope you check it out. It's reservation ready. We're offering it on our site only, direct to consumer. But our second business model is then this licensing and design deals that we have with the other segments and verticals. And we think it's core for any company today to build a brand, even if you're in technology. So we're working with the product as the driver for the technology, and technology as the enabler for the bike. So check us out, and we're pretty active on social and on our site. And hit me up if you have ideas of things we can do together. We think that this approach and this method that we have patented, could be used by many others. So, yeah, we have some ideas on boats as well, but it's early days. And the output, just to summarize from the tech, is less parts through parts integration, and that's mainly done through folding structures instead. And less weight by actually using less material by having a fixated structure. And the result is less CO2, up to 70% less CO2 in the process. But that's partly because we select the right materials, of course. Cool. That's the end of this presentation, and hopefully you reach out to me. Here's my contact information, and let me know your thoughts.